There we go.
Hi, so we're Team PACE. I'm Tom, and I'm joined today by Stephen, Rachel, and Filipos. Whilst we come from very different disciplines, this project has really struck a chord with each of us, and we're incredibly proud to present what we've created today. So we are partnered with a charity called PACE, who are a charity that provide education, therapy, and support for children who live with cerebral palsy and other similar conditions. PACE itself functions primarily as a school, creating a space where their students can grow to thrive. Part of how they achieve this is by using a huge variety of assistive technologies in their day-to-day running. Assistive technology itself comes in many forms, but today we're going to talk to you about assistive switches. These switches provide direct control to electrical devices for people who would previously be unable to access them. PACE introduces children to these switches at a very young age and then gradually progresses them to using more complex systems as they're able to grow and learn. This simple technology can then open the door for their students to learn to communicate, move themselves using something like a powered wheelchair, or control their immediate environment without assistance, all of which are tasks that otherwise would have been simply unachievable.
Throughout a child's time with the PACE Center, their switch systems are assessed by occupational therapists to determine their individual strengths and requirements. To perform these assessments in a child's home, an occupational therapist brings along a large collection of switches and interfaces to test, which, as you can see from the slide, is no small feat. The process where an occupational therapist sets up the equipment to assess a child can be very overwhelming. Many current devices are massively complex, too bulky, and have limited customizability options. The switches can also be intimidating to the children, resulting in them choosing to avoid using them. Furthermore, this project has revealed many pains beyond just those of the end users, the most substantial being the price, with many basic switches costing upwards of £100. This causes massive complications not only for charities with strict equipment budgets, but for families trying to build assistive systems in their homes. Overall, all stakeholders suffer from the outdated technology and difficulty in tracking the child's progress while using the products that are currently in the market.
To take in the market as it stands was actually quite startling. We realized early on that to democratize this area of technology, we needed to rethink all facets of the switch system from the ground up. That's why we have built an ecosystem, one that impacts the simplest way a switch is set up in the home and how it's used years down the line. One that not only replaces off-the-shelf switches, but integrates them wirelessly. Essentially, a system to sit at the core of any assistive household. Let's take a family in need, using our system with their 6-year-old daughter, Jackie. Now, like many children with cerebral palsy, her switches are a huge part of her life. Her mom has just bought a new toy, which is a bubble machine you can see in the middle. So now we can have a look at how Jackie learns to play with it herself. Jackie's mom has already got our system in her home, so to connect the bubble machine, she first chooses the switch she wants Jackie to control it with. Here, she chose the simple green button. Now, to get it up and running, she places our wireless communicator inside. This is what gives the switch its power and what pairs it to the hub. We can see she's assembling the switch and then plugging it into the power supply so that now it's ready to connect. To set up the bubble machine, the process is even simpler. With a smart wireless plug already set up, she simply plugs the toy in to control its power supply. To connect these devices together, Jackie's mom turns to the user interface. Here, she starts by adding the new switch as a device. So she gives it a name, she calls it the green button, and she fills in all the device details. Once she clicks add, the device is paired, and she navigates to the home screen where she sees a Flow dashboard, which is a log of all the existing configurations. So she's clicked create new flow, and she adds the input, the green button. Here, she also specifies how she wants Jackie to use the switch, so the fact that it's held down. She's put in the output, and finally she sent it to the central hub. So now, whenever Jackie holds down the button, as you can see, her bubble machine turns on.
Every time Jackie uses the device, each of those button presses, the action is logged. If her mum or her occupational therapist navigates to it, they can see trends in the usage data and see how effective Jackie is at using each switch in each flow. Now on this page, she can see which switches Jackie is using most, or how often or whereabouts in the house. Okay, so Jackie's mum is pleased with how the system works and wants to add a new switch, one with a custom shape. She navigates to the Access Hub, which offers her the opportunity to order a custom switch, as well as lots of other features which make her feel a part of the community, such as talking with other users and sharing their experiences and ideas. At the Access Hub, she goes to order the custom switch, and here she'll find an optional additional tool that will help her identify the perfect switch to fit her daughter's individual requirements. This is following a similar process to how an occupational therapist would assess the needs of a student, such that this can be done whether or not the family has access to an occupational therapist or a 3D printer. So Jackie's mum then parameterizes the switch to Jackie's hand size, places the order, and now it's on the way.
You've now seen how our primary actors are interacting with our system. We've come a long way since the inception of this idea. What was a sensible way to implement and put this out into the market? Well, here's our three-part ecosystem. Consisting of the wireless unit, the hub, which is a Raspberry Pi, and our dashboard user interface, not only we're decreasing the cost of switches through the wireless unit, but we're making the hub interface interaction more intuitive, and we're letting occupational therapists and students configure the entire system in one globally accessible platform. We're relying on four main facets to make all this happen: reducing costs, simplifying setup, modernizing hardware, and improving accessibility.
Now for the first branch of our ecosystem. To better meet the fundamental goals of switches, we're doing away with the current hardware and rebuilding the switch from the ground up around our new wireless unit, the WOO. We're compacting this most expensive part, which is the hardware, and we're making it reusable, such that this modular communication unit sits at the core of every switch and links wirelessly with our ecosystem. That means that now, to get an entirely new switch, you need only change out a 3D printed casing, which instead of hundreds of pounds, costs pence to the end user.
So our hub is a device that sits in the home or school and controls the interactions between multiple rooms and various outputs. It does this wirelessly and, as you've seen, has quite a simple user interface which allows any user to create and modify configurations with ease. These configurations are now fully customizable, no longer being limited by the hardware interfaces available. In future, the community will be able to create and share custom functions and configurations, incorporating existing smart devices such as the Xbox accessible controllers, Google Home, or Samsung smartphones. With thousands of IoT devices available on the market, this access drastically expands the autonomy each user has over their own home, controlling lights, appliances, doors with the click of a button. So, as previously mentioned, the hub can be configured to record usage data, which we believe could help kickstart a new age of therapeutic analysis. Our product puts this data directly into the hands of the occupational therapist, removing the complications found with manual recording, allowing for them to make enhanced insights into the progress and development of each child. In future, this process can then be further streamlined with the introduction of advanced machine learning techniques and data analysis. So this system is built using a lot of different moving parts, but primarily our front-end hub application is built using React.js, which then communicates with a Python API that controls an instance of Node-RED and a MySQL instance on the hub. Our WOO devices, depending on which model, communicate to Mosquitto, which is an MQTT broker, either over Wi-Fi or Bluetooth Low Energy. We then use our Node-RED instance to orchestrate these devices via MQTT and send commands between devices.
Now, all this effort means nothing if we cannot put our product into the hands of those that need it most. Using the principles of open source and open hardware design, we know that to sustain a project of this magnitude means walking the line between community and business. This is why we have put great thought into how to bring this product to the market, as not only a competitive switch system, but one affordable and available enough that our target users can get their hands on them.
Looking to the market now, one of the most comparable wireless rechargeable switches costs a staggering £125. Now, in the simplest manifestation of our product, where all 3D printing would be done through third-party services, a single unit costs only $26.66. And if printing can instead be done in-house by us or a charity, that price drops to just $10.66 per wireless rechargeable push button. So as you've seen, this project comes with a unique set of challenges. And one that is important to us is how we can make this system as available and accessible to all. To ensure this, our hardware is to be sold at cost, and our software is planned to be free and open source. This brings the obvious complication of running costs. There is an inherent upkeep that needs to be covered, and crucially, we don't want to make our end users have to foot the bill. And so the model we have proposed is a foundation funder model, where an organization such as the JS Foundation will support the project financially through a number of sponsor partners. And we drew inspiration from other similar open source projects such as Node-RED, which show that this is a viable option.
Now, we recognize the resources required to build an ecosystem like the one we envision, and this project is larger than the Woo hub and UI that we've created in 12 weeks. This product has the potential to sit at the core of every home, seamlessly integrating IoT and assistive devices alike. We feel that it has such power to give autonomy to this generation of kids, and thus we've spent much time laying out a vision for how to make this the best possible product before it hits the market.
Why does it all matter? Well, we're aiming to offer great access to essential technology for people with disabilities worldwide. And we're doing that at a lower cost. We're also offering better customizability. More children will be able to use switch systems to interact with their friends through an online interface. More users will be able to control house appliances without the help of a third party. Through our solution, we're making life more accessible to those that truly need it. Thank you all for listening.